Okay, so let's get R to do some of the hard work for us. Just to remind ourselves of what the problem is. So we have the scores of an armed force aptitude tests are normally distributed. They've got a mean of 73 and a standard deviation of 14.3. And the question we want to answer is what proportion of scores are above a raw score of 107. So the first thing that I'm going to do is I'm going to just load up here this particular package, ggplot2. The reason that I'm doing this is in a moment I'm going to make a little plot. Now, you normally wouldn't have to do this. I just want to illustrate what the nature of the problem is that we're looking at, but drawing the plot is not in any way integral to solving the problem. So we'll just load that up, highlight it and run. And I also, to help me draw the plot, want to draw on a function. Let's just run that here. Again, this is not something that you need to do, or you would only need to do it if you wanted to make a nice plot similar to the one I'm going to produce in a moment. I didn't write this particular function. I rather shamelessly borrowed it from someone else. But yeah, that's basically how things go here. Now then, let's do the first thing that we need to do. Let's calculate the Z-score corresponding to 107. Well, that's very, very easy and straightforward to do. We simply make this little calculation here. 107 minus the mean of 73 divided by 14.3. We're going to then assign the result of that calculation to Z here. This arrow here is the assignment operator, and if I just write Z down here again, R will print the answer out. There it is down there. The answer is 2.377622. Okay, so we now know that a score of 107 corresponds to a Z-score of basically 2.378. So now let's make use of the plotting function. That's this function here, normal prob area plot. You don't need to worry about the details of this. It's not very important. Just think of it as a little kind of abracadabra, which is going to make a little plot here, which is going to clarify for us the nature of the problem that we're trying to solve. So here's the standard normal distribution. Here is a point which is 2.38 standard deviations above the mean. And this is the area here that we're ultimately interested in finding. So we now need to get the tail area, which is greater than 2.38 standard deviations above the mean. And surprise, surprise, R will have a function, or does have a function, which allows you to get that number. But there's a little twist. There's a little difference to what you've been doing earlier when you were looking at the table of values. P-norm returns the area up to 2.377622 standard deviations above the mean. In other words, what P-norm does is it doesn't give you this area here, which is what you were getting from the table. What it gives you is this white area here. Okay, that's no problem, because all we have to do is subtract the result from 1. If we subtract the result from 1, because we know that the area under the curve here sums to 1. If we subtract from 1 this area here, then we'll get this area here. Okay, so I've assigned the result of that to P. P-norm takes some arguments. First of all, what's the in this case the z-score that you're interested in, the number as it were up to which you want it to give you the area. What's the mean of the distribution? If it's a standard normal distribution, the mean is obviously 0 and the standard deviation is 1. So let's just highlight that and run it, and then we get our answer down here. This area here is 0.0087 blah 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 blah. It's less than 1% of the total area under the curve. Okay, so that gives us our answer. If we go back to the original question, what proportion of scores are above 107? The answer is 0.0087123339. Now, actually, we could have cut out the middleman here. There's actually no need to find the z-score because this R function P norm will give you the same answer with the raw scores, the original mean, and the original standard deviation. In fact, it's actually rather better to use the raw score, and in that way you eliminate any potential rounding errors from the intermediate calculations like computing the z-score. So down here you can see that we've got essentially the same thing again. We're going to use the P norm function. I'm going to assign it the result of it this time to P1. We're going to subtract whatever the result of calling that function is here from 1, just for the same reason that we did before. All that's different is we've got the original values in here. So the score above the mean is 107. The mean, the original raw score mean was 73. The original raw score standard deviation was 14.3. So if we just run that, you'll see that basically we get the same number. This difference here is actually attributable to the rounding error from having done that intermediate calculation of calculating the z-score. So actually you can see here that it actually is more sensible in this case to actually just work with the raw scores.